Welcome back to Algebra 2, Chapter 6, Section 2 in this book. And we're talking about polynomial functions. Now, what does that mean? And boy, that looks complicated. It's not. You're going to be fine. Alright, so polynomial, poly means many. And what it means is that we can have many terms. See, each of these things is a term. It's like the quadratic equations that you've been doing. And then remember that you can have f of x or y or 0 and it's all the same thing. As long as it's a function. Okay? And so what they have all fancy looking here is a is the leading coefficient. X is your leading variable. And you put them in order. What it's trying to say fancy here is you put the biggest exponent term first. You put them in order by the degree in descending order. So it's x to the third, x squared, x to the 1th, but we don't put that. And then a bare number with no x's at all. Okay? And so this is saying that this is just, you're subtracting one from the exponent, and that little symbol means bare number. Alright? So this number that goes with the x that has the highest exponent is called the leading coefficient, and it's important because if it is positive, your graph ends up going up. And if it is negative, your graph ends up going down. So that's how you tell if your graph's going up or down. Whether your degree is even or odd tells you more things. Your highest degree, which is your highest exponent, which is called the degree. So that also tells you what the shape is going to be like. If you have no x's and it's just a bare number, then that's a constant term. That's like pi or something like that. If it's got one x and a y and or a f of x or whatever and no exponents, then that's linear. It's a line. If it's x squared, it's quadratic and it's a parabola. There's my a right there, which is that U shape. If it's to the third power, it's called cubic, and it kind of does this, or it can do this. You'll practice this on your calculator and you'll get good at this and this. Okay, so that's cubic. If it's to the fourth power, it's like a parabola, except sometimes it has a little wavy thing. So the parabola can go up or down, and the quartic can go up or down, just like that. Now, this is how you can tell what it's doing. We already said if the leading coefficient is positive, it goes up. If it's negative, it goes down. So if it's a line, it would be like that. If it was negative, that if it's positive. If it's a parabola, it looks like this if it's positive. It looks like that if it's negative. Okay? If it's cubic, this is positive. Let's see if I can do it. That's negative. It goes down, but it's sort of like a line, but it has like a bump in it. Okay? If it's a quartic, that's if it's positive going up. And then here we go like that if it's down. And that's what this is saying. If the exponent is odd, not the leading coefficient makes it go up or down. But if the exponent is odd and the leading coefficient is positive, then it goes up like this. If the exponent is odd and the leading coefficient is negative, it goes down overall. If the exponent is even, then the two ends end up going the same way. Notice if it's odd, one goes up, one goes down. It could be this way or that way if the exponent is odd. But if the exponent is even, like in quadratic equations or quartics, the arrows end up going the same way. If the leading coefficient is positive, they both go up. If the leading coefficient is negative, whoop, they both go down. It can have a bump in the middle. Here are some pictures, and you also have some in your book, but that's the trend. And your book it has a little green box about this. I think it's very confusing. I think me doing it is better. That if the exponent is odd and the leading coefficient is positive, whoop, if the exponent is odd and the leading coefficient negative, whoop, if the exponent is even and the leading coefficient positive, whoop, and if the exponent is even and the leading coefficient negative, doop, there. I acted out all the graphs for you. You can act them out yourself. Alright, so this is function notation, and it could have f of x here, or sometimes if there's something there, you substitute it in. Now, I recommend you sing the song first. Substitute. You can do the pointy dance too if you want. Alright, so wherever there's an x, we put in a 3. We put it all in our calculator, bada bing, bada boom. The answer is 98. Very easy, you just have to know the notation. Your calculator will do all the work for you. Alright, now there's something else called synthetic substitution, which is we can do the same thing much harder. Why? Why would we want to do it harder? Because it is training us for something coming, which you do need to know how to do, called synthetic division. So let me show you how it works. What you do is you take all the coefficients and you write them down. So the coefficient to the fourth power is 2. Notice there is no to the x to the third power, so its coefficient is 0. You have to write that down or you will get the wrong answer. So for every 1, 4, 3, 2, 1 bare number, you have to have a number. Okay, now for the second power, it's -8. X to the first power is 5, and the bare number is -7. Then you write this big L, and then you put what you're substituting in over here on the side, and usually I like it to go more right there. I don't know why I wrote it down so far. Okay, then I write a little plus sign here to remind me what to do, and a multiplying sign down here, because it's easy to get confused. I told you it was a little bit harder. You draw an arrow under the 2 and write it there, and now you're ready to go. You do 3 times 2 is 6. And then 0 plus 6 is 6. See how this is your addition line with the plus there? So that's why my times is down here, okay? So now I do the 6. 3 times 6 is 18. -8 plus 18 is 10. 3 times 10 is 30. 5 plus 30 is 35. 3 times 35 is 105. -7 plus 105 is 98. Ding, 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 same answer. We're doing the same thing, but much harder. But I promise it'll be worth it in the end. I want you to practice everything, all the examples in your book with your calculator. I want you to graph all these crazy things with your calculator. I want you to see how if it's cubic and it's got a negative leading coefficient that it does this. I want you to practice all of these so that when you see an equation, you kind of know what it looks like. See, I look at this and I go, oh, it's to the third power. This is even. It's going to look something like this. It'll go up at the end, it'll go down at this end, and it will have a little wiggle in the middle. So, you need to get where you can do that too, where you can kind of know what it's supposed to look like before you ever graph it. All right? This is fun. Come back, we'll learn more. Math is great.